For today's webinar, I'm excited to bring you a consumer part. So today's is a little different than your typical consumer part. I'll just go ahead and jump right in. It is a mask. As you can see here, lots of different designs get created and simulated in different 3D softwares, as well as people designing things manually, in clay and foam and wax and all these different types of traditional methods of industrial art, and creating these objects, and then being able to, in this instance, 3D scan that shape and reverse engineer it for manufacturing purposes. So as you can see here, it looks like this design was created in a physical form, and on the left hand side there, the blue object is 3D scanned, and then taking that and doing a lot of DesignX surfacing, as you guys can automatically anticipate today, especially since it's yellow. That's how we color our open surfaces, as yellow objects. So you could imagine how many different applications there are for this throughout the theme park industries, the media industries, all different kinds of areas where art designs are being created and need to be manufactured. So being able to take those 3D scans and move them over to the digital world for manufacturing. So with that, we'll jump over to the scanner slide. With these types of objects, I do believe it was a handheld scanner that collected this one. So you see devices like this right here, this one right there, this one, that one. All kinds of different handheld devices work really well for these character designs. Again, as I said before in other webinars, it doesn't mean that these scanners, other scanners, could not do it and not do it very well, because the scanners all have their pluses and minuses, and they overlap each other in functionality. As far as a lot of them can collect data at an equivalent detail level or accuracy or whatever, but they have different methods. So common extremes are the fact that this is a blue light scanner, so it's a stationary, sitting on a tripod taking shots, and you would move it around or move the object on a turntable. Same thing with this one. Same thing with this one, where, a handheld, you could move the handheld around it, and sometimes it's tracking itself based on targets that are on the object or around the object or on the ceiling or wherever. And you can see how this one would have advantages in certain instances, and these would have advantages in certain instances. A lot of times with the blue light, resolution and accuracy is a advantage. And then you see here with these types of scanners, the longer range devices like this one, and right down here, these sit on a tripod and spin around 360, and they shoot scan in a 360 horizontal and like a 320, 380. I mean, 380. They do amazingly. They do 380. No, 320, 280 is what I was saying, depending on models, and some of them have a handle on top and things like that. These things are very flexible for scanning environments and stuff. And the trade-off is these are lower accuracy compared to these and even these. But again, it's all about what you need. Scanning very, very large objects, these things do a phenomenal job. And then, of course, you can strap this type of technology to a drone, and you see this where we can fly this up. So this drops accuracy down even more than these. But you're able to fly this around a tower, and collect scan information on it. There's so many neat things that you could do with this type of information. And then, of course, these things are nice because you have the ability to touch, probe, and scan at the same time. So you have this device that I could probe things and capture like mounting point locations at a level of accuracy even higher than all of these, um, because you're touching it and probing it. Um, but yet you also have a laser on it as well to capture the overall shape. And then this is a shrunk down blue light scanner to where you're bringing this envelope down to a smaller, to up the resolution there. But yeah, I just wanted to point out all of these are toys to me. I absolutely love 3D scanners and what they do and how they capture information. And I love geeking out over the different types of devices that are out there and all of their benefits. But today's, I believe, was captured with a handheld scanner. So with that, we'll go ahead and jump in to the application slide before I jump into DesignX. So as usual, we always start out by just going over this slide, and I will pare it down. As a lot of people are watching my webinar on a regular basis, I know that going over this slide could take a few minutes, and it's redundant for you. But I just wanted to make sure that anybody that's watching this for the first time understands what DesignX is really quick before we dive into the application. But DesignX is this software right here. It's the software that we use. It is a software that can work with 3D scan data from a variety of different inputs from different devices like these over here on this side, from structured light scanners to laser to handheld laser structured light scanners, time of flight scanners, CT scanners, even all kinds of different devices. We're creating this type of data, and people were trying to load it inside of CAD. And we're struggling a lot because CAD wasn't designed for this type of information. Enter DesignX. We create this software that is a parametric CAD modeling kernel with a 3D scan kernel all in one space, right? So then we take this data, do the heavy lifting, and then we extract model information and output it in different sources like you see on the right hand side, whether these are the high level outputs. CAD is the primary, but we also go straight to CNC packages or straight to additive technologies out in the market. So that's what this DesignX product is all about. Grabbing that scan data, recreating or reverse engineering that object, and getting it out to whatever is going to produce that manufactured model. So with that, we'll go ahead and jump right into the DesignX portion. So here is the final model. I tend to like to show the final model before we get started so you can kind of see the direction that we're going to go here. And we will go ahead and show the scan data. Turn that surface off. You can see the scan data. Now let's go ahead and roll back. So come back here to just after the region group. So there we are, roll forward. Looks like we're fitting surfaces. Went ahead and fit a surface to that front with using the mesh fit. And those of you that haven't seen the mesh fit before, it's right here. If I just come over to mesh fit, turn on my regions, turn off the other mesh fit, all they did here is just click on that region. You see that you have the ability to move. This is what I consider, when I teach the class, I drape a piece of fabric over that shape, right? And this is going to be the square of fabric that we're going to put over top of it. And we hit next. You see that? And then you have the ability to adjust the control net density, some other tolerances and things like that. And then you can create a new one. So you see it was very quick to be able to create that um, mesh fit. And did I just click roll to end? So we'll just roll back again. Roll back there. There we go. So now we're going to roll forward, and we did an extrude. So let's turn on the solids. So we did a solid here. So it looks like they clicked on this front plane and then did an extrude with draft. See that? There's many ways you can approach something like that. Some people would prefer to just do a rotational, right? A revolve. Some people think that way. And then this one, since it is just a constant, you can just add 10 degrees of draft and accomplish the same sort of deal there. A couple more mesh fits. So we did a mesh fit across the forehead there. And one along the side, which is turned off there. Okay. So you see there on the cheek area. Then we went and we deleted, it looks like, the back surface of this to make it a surface. Because as you saw at the end, the goal for this one is they're creating a zero thickness surface. That's the kind of the deliverable at the moment. Yes, you could offset it, thicken it, things like that to create a solid. But whatever the scope of this project was, that's what they chose to do. So maybe they could have been using that surface to cut it away from a solid to make a mold, right? So there's lots of different reasons why you might want to do that. And you see now we went ahead and they fit a surface cylinder there. So with that sort of thing here with these regions, you could still use the extrusion wizard maybe on this side where you click this, and when you select that, it would then, I meant to change it to surface there. And that's kind of what, I bet you that's what they did here, is they used the extrusion wizard and then created a cylindrical surface. And you see this one is two together, but it's the same general concept there. So you see it's very quick to be able to fit those. Now we'll turn these other ones on because I'm not sure the direction it goes yet. So roll forward. They went ahead and actually, let's do this again. They did the same thing for this right here. They could have even visually looked at it, right? If I turn off regions and visually look at that, find the direction. And here's another thing. Yeah, for objects like this, art objects, if I see that there's the extrude direction is in this direction, I can calculate an extrusion direction by coming into vector, selecting scan data, and then come over to extrusion axis, right? And I can calculate it that way. And I can select, actually, let's just do it here. I'll just say I'm selecting that. I want to calculate an extrusion axis from that. Hit OK. And you see what it's doing is it's saying it looks like it's calculated from this direction right there. And then I can intersect a point, create a plane, and then put a plane there and draw the sketch for that. Now for this one, I could even just look, and if visually I can see, yeah, I would really want the extrusion direction to be right here. Another way to do that is come over to plane and say, I want to create extrusion based on my view direction right here and this point. and hit OK. So I just looked at it and created a plane, and I could just draw my sketch on that plane, extrude the surface. So you can do this all over, right? Like if for some reason it's really hard to calculate an axis or whatever in a certain direction, I can just manually make one by looking at it, rotating my model to wherever it looks good, and then say, oh, that's where I want. I want the extrusion direction for this to be right here, and then create a plane view, square to the view, right? Now you can also create extrusion axis or revolve axes. That's what I wanted to bring up as well. That I can select all this geometry here, and I can calculate a revolve axis. And I just over selected on accident, but not a big deal because I can come in. We'll just disconnect it from everything. Now, like this, all the way around. Okay, I didn't have through on. You guys have all done the same thing too, right? Everybody has done this. Turn on through. Now I'm gonna do this, and now I don't have it all the way on screen, so we're just gonna have to do it multiple times. I was just doing it this way just to show, like, hey, you don't have to just like start all over again. But I should have just started all over again. In this instance, right? Is sometimes you just like, you know what, just start over. But this does give me the opportunity, to show different ways of going about something. Now, if I come over here and turn on visible only, I could do this way for this backside. Oh, why did it skip that? There we go. Anyway, so my idea here is that, I can create a selection of a revolved axis, and I spent way too long, and I can hold shift and add to it, and then hold alt and then I can hold alt to change my paintbrush size, hold shift to add to it there. So what I'm saying is, hey, this is, if I want this to be a revolve, I want to calculate a revolve axis from this. I can come over and say revolution axis. Or if this was only a cylinder, I could use that. It would be fine-tuned for a cylinder only. Or I can say revolution axis, and then it will calculate the wrong one. So actually, let's just do it over here. We'll delete. You can edit this. Did I revolving axis? We'll just come around here. I'm just going to do it a little quicker this time, and not waste so much time now. Just down, just quick. Then hit that. There we go. All right, so you see, I can find a revolving axis by revolving shapes here, and the same thing goes here. I can really quickly select all these things that would make up a revolve. And I'm bringing this up because people were asking me to cover more about creating reference geometry from scan data. So I could say revolving axis. And why does that do that again? So just come right back over here and revolving axis. And I just need to add more to it. Like there are instances where it's like this is way too far off, right? That's what I run into sometimes where it's like it's telling you, listen, especially with revolve axis, it's really working to try to find a good accurate revolve axis. There we go. So after doing it a bunch of times, you see that we can calculate that. Now, while I'm on the subject, if I wanted to find the sphere center here, super easy. Select that sphere, come over to point, find sphere center. Okay. See that? Very easy to calculate. So if I select that top plane and I say from that top plane, extrusion axis. No. We don't want to do that. Um, I want to extract the plane. That's what I was doing. So fit that. This is the most common. Everybody does this, right? So there, we fit a plane. But being able to extract these things on here is very valuable. To be able to select geometry, there's a ton of different methods for calculating extreme position. So extreme position here, if I just select this, it's going to put a plane on the highest point, which is the highest point of the other direction. You see that? I can flip that if I wanted to. If I come over here and edit, you can change the normal direction of which way you want the extreme position to go. But the idea here is there's really good, powerful methods for extracting reference geometry. And I wanted to cover some of those while I was here at it. Just being able to quickly, um, create some reference geometry. So, for example, here, if I do this, point, find sphere center. All of those points. So we can actually select all of these points. You can come back in and say, I want to pick multiple points and average those together and find a center point there between all of them. So just a little tutorial on calculating some of this stuff, just creating reference geometry. I just thought that would be helpful to kind of pause that. So now let's go back. So there is our surface. We got a trim. We went ahead and trimmed those two together. Looks like they do a mesh fit down here on the bottom side of the jaw. We did another one in this direction. Again, we could have calculated that manually or just looked at it in this direction and created a plane. Now they're going to trim those. Trim all these pieces together. Now we create this. That's a cool surface there that we extracted there. And now looks like we're going to drop down and do a loft on the cheek there. And then start trimming some stuff in. Oh, we did extend first. Still creating. So create some surfaces here. Now we're going to do some extends and trims. We're going to mirror it across. Now, some people will say, hey, Why don't you just mirror the thing at the end? I think they're mirroring this across right now at the moment just to be able to trim and find that center, right, for this surface here, and then create that fillet at the moment. They're still going to mirror the final anyway at the end. And then you also can do this just to check and see how symmetrical this is as you go at the moment, just to say, you know, is it very symmetrical? Do I want it to be, things like that. Now we're going to, looks like we just did another fit up there, extend, trim. See, we're roughing all of this in. Now you notice that they're kind of taking this where we're wrapping around here, around. We started here, and then we're wrapping around and trimming all this together, and it looks like they're going to trim this and this probably near the end. So they did a split face there. Sometimes instead of doing a surface trim, you might just draw a 3D sketch and do a split face and then delete a face, right? Sometimes it's just easier to do that because of the way that was curling back around, to use split face, delete face versus trimming it with surfaces. Now we trim all of this. So now just keep on moving on. Surface sphere, where was that? Here. Let me just edit it. Oh, right there. I don't know why I was looking past it. So we went ahead and created a few of those and sew those in. All right, this part is really kind of neat actually. So I wanted to turn that off. And if I edit this surface, you'll see that it is a loft between the edge of this trimmed surface and then it is a curve that was drawn on the mesh. So let's just come back here. So they drew a 3D sketch right there on the mesh here. So they just went into 3D sketch and drew that all the way around. Then did a loft between that edge and here to make that eye socket. So that's a decent approach for sure. Now, extend, trim, trim that in. They add some fillets to that. What are they extending here? Oh, we went ahead and extended interior to intersect it with the eye. And then now they did a extend surface and an extend surface extrude along that direction there. Surface offset. Now trim. So all of that together. Oops. Roll back. I think I hit roll to end there. So now, just turn that off and see where we're at. We still have this piece, this chunk that needs to be merged in with the others. But first, they went ahead and added a fillet to this chunk. And we did some, oh, there we go. We trimmed that piece in with all the rest. Now, a bunch of fillets all around the eye, getting those all knocked out. Now we go ahead and cut that little piece there away. See, if we turn off surfaces, you see there's a little piece there that's cut. They modeled that as a solid originally just because it's easier to do that. Then, okay, trim that away. Let me see here. Oh, up here. There we go. So now we went ahead and created that surface, this surface, and trim those in. Flip the normal back and trim that down. Now, let's do some filleting to fillet some stuff. Yep, all up here. Then we finally do the delete face over here to make that a surface. They went ahead and added a missing fillet to that. Trim that whole piece in with the mothership. Mirror. So now they went ahead and saved those last pieces, the spheres. For at the end. Now they're adding some fillets to all those edges there. Let's see what this was. I forget. Oh, the little nostril type areas. So in those instances, they did it as a solid, deleted the back, mirrored it across, trimmed it in, reverse normal, fillet. Now cut the inside of the eye away and fillet. Really cool design process here. And we'll go ahead and turn that sketch off. So there's our final model.